which of you is going to start first?
I can start, but it'd be nice to have work.
I'll start.
Either way, you're going to stop coding right now.
All right. Well, make me start.
Alright.
Oh, let me get a pen and
If you'll excuse my attire, I'm still dressed up as a burglar from last night. Choose my outfit because I didn't have face paint to make a skeleton.
that's why I have a haircut. And remove part of my costume.
Choose Mr. T.
I did.
So,
I have a little. What is this? Hold on.
Here, I'm gonna check your code that doesn't work. So. Is this on there, right?
What's that? It's on CVS Web, yeah.
Yeah, I'm gonna check in some bad code.
tag it.
No, we're already tagged stable. You guys can break it as much as you want.
Oh, it still works. Like, this won't break anything other than
Does it still compile?
I'm just getting a smaller runtime.
What does this does?
I use Cord.
What are you looking for? Yeah, I got that.
A research paper so that I can write on the back and it's the same material. It's my filing system.
Alright, so it's on me, right? Alright.
Proceed.
This little guy. Right here. It's me.
Alright. You can pull up the code if you want.
Okie dokie. Let's see.
Now, have you tested this with the new threading model?
No, I
New
haven't.
threading on?
Yeah, everything's a thread. The
Alright.
applications.
I send out emails to the address that I have of you from the beginning, alright? Check the emails. I put stuff up on the
I got it.
wiki. Alright? I don't know. Subscribe to the anybody, do you RSS?
Yeah.
Huh? No, do you read email?
I didn't get the email.
Do you have any
You
forms
got it,
of-
dude. I saw we
No,
all.
I did not get the email.
Oh,
Alright, well check your spam folder and put me on your exception list or whatever because...
alright.
Okay, look, at the very least, barring any kind of communication from me, you check the wiki, you look through CVS. That's the only thing you need to do
I'm
before you
scared I
come.
gotta make more changes if I look at CVS.
No, you don't have to make that many.
Look,
Alright.
if I check stuff in, chances are you don't have to make any changes, alright? Unless you're not checking the latest CVS before you start coding. But all I'm saying is
Alright,
wiki and CVS.
so base console. Here's the console. It's not much right now. It's pretty
I can
basic.
see.
Yeah.
I can't see.
Oh, you can't. Sorry. How about now? Alright. Better? Okay, doke. So, right now, here's my constructor. I'm not using config object. Let's see. I don't even know why I have that in there. I can take that out because I'm not using it
Yeah, you don't ever receive start, right?
right now. So I got my start IO, request quit, and my slots are start IO, which will run main, and apps request quit, which will quit. And then I submit start IO to kind of jumpstart everything. Let's see. Actually, I think, yeah, here we go. Run main. Run main calls my run method. Just kind of chunky. But,
Actually, that'll be drastically simplified with the new model
yeah.
because you can actually just put a lot of that stuff in. You have your own thread now, so you might be able to integrate that into the thread.
Yeah, well then, I'll just make it extend abstract module instead of
Right.
implementing a signal motor and extending thread. Alright, it doesn't do much. It's just this kind of ugly little printout thing. It's basically what you had earlier.
Okay. So you take in input.
Yeah, so I take an input, I'm a punk and I was using strings. Just cast it to an array and take the first array. Quit, start, or load. Loading. I don't have loading yet. I'll work on that. Is that it? What else? This is all the other stuff that comes along with. Yeah, just not even. That's it.
Does it have the, like, can you pick, like, create group shit and that type of stuff?
Create.
That would happen through
Yeah.
the load.
Oh, okay.
What I'm planning on doing is having something like. Let's see, mark. Does this one work? Yeah, that's pretty. If I can do that thing that we talked about earlier, because I don't want to have like
If you can do what?
the thing I was talking about earlier about just overwriting
Uh-huh.
instead of having to keep printing out new lines. It's weird. But when we load, I just have a little, maybe have something like this. I don't know yet if I want to do that still, but whatever. Or if I just take an argument. But anyways, you run the console and you be like, what do you want to do? And then that would be like your command line, and then everything under that, it just print what's going on. Like that way, it wouldn't have to, keep asking you, keep printing it out.
Okay.
Because this way, you could check with like what's going on in base, and like this would just be like, whatever's going on, it prints right here, and it'll just overwrite. Like if it found groups, if it found a paste group, list it, and that way it's just up here if you want to join, enter which one you want to join. So, I don't know.
Okay.
That's
I mean,
it.
I'd recommend not going that far to erasing the screen and not making it kind of look like a menu. I do it more like a shell.
Okay.
You know what I'm saying? Like something that, because we want this to be as simple as possible.
All right.
Because anything that's going to be like menu-ish or whatever, we have better interfaces for that, I think. I think like some options are, I mean, obviously there's the GUI, but even without the GUI, we have options of like making like a web interface or stuff like that. I envision like the console. I know the first application I want to use the console for, and that's running it on
All these guys.
all these machines. So it should be thought of as really, I mean, it should almost be scriptable.
Okay.
So that I could echo things to it or whatever, or give it like, or take, basically have like a file that's a standard input and then just redirect standard input to it so that I could run all these machines at once and then, because what we're going to have is we're going to have 26 of these. So the more interactive the shell is,
All right.
the more every 26, 26 machines we have to do something. So, I mean, I think along the lines of printing out the menu, and I mean, you can even be more terse than that if you want. In fact, you don't have to tell them what the keys are.
Yeah.
So,
All right.
but
So just to end up changing something to like console.
yeah, like a paste
Command line.
prompt or
Yeah.
something. Yeah.
Just print it out. Or you just set the command line paste console and have your arguments there.
Yeah, and then you
So
just.
load, join, find something.
Oh, I don't know about with the what's it called. No, I mean it'll have to be interactive because we
Okay.
we don't invoke paste console. Paste invokes paste console.
Okay.
So, but something along those lines where you get like a paste prompt, like like a shell prompt, like a pound or something. You got
Yeah.
a paste bracket or whatever, and then you start typing in stuff.
Okay.
What else? So yeah, maybe take a look at the new abstract module piece, so that you can see if you can integrate into, because you get a free start. Yeah, because you know how you had to kind of send in a signal so that you can instantiate and then start.
Mhm.
You get a free start because of the because since you're on your own thread.
Okay.
You might still need to invoke, but I mean, I don't know. You can look at it. And
I'll
in
tool
fact,
around with it tonight.
the other thing is that you might not want to use it at all. In that you might be just your own thread off of the main thread. I mean, a wasted thread doesn't matter. I mean, since our event queues wait. I mean, since they sleep when they don't have any events, you don't waste any processing power by having that other thread. So if you're doing something, that means there's no signals in the queue. That's thread sleeping. If it's doing something, that means there is a signal in the thread, and you're still waiting to get it. You're probably going to want to also handle, what other signals do you think you're going to handle as far as slotting?
Let's see, like if I'm using, we'll be using Juxta. I want to know. I'm gonna have to take a look at Juxta again to see what it emits when it like finds groups.
Right. So I take a look at the GUI.
Yeah.
Because it catches those. And I think what we need to start doing is building the list of signals that any user interface would probably want. In other words, there's a few signals like the one you're thinking about is the Juxta emitting that a group was found or whatever. Yeah, and it emits something, but that's going to be kind of it's actually, the Discover actually builds a group for it, like in the group model, and then it also emits there's like kind of a generic signal that is emitted when a group is updated, when any of the group models updated. So you probably want to receive something along those lines, and then obviously the interaction from once you get the load. You're going to go through it's like you send it out, it goes and does a bunch of stuff, and then you'll actually get that same type of signal back.
Yeah. I'm going to have to change this quitter too. I don't think I should tell it to stop first.
Wait, what's that?
For this quitter right here that I'm using, when I receive the quit signal, when I just do system exit, wouldn't it be better to...
Oh yeah, you don't want a system exit.
Yeah.
You want to you're going to need to... That's in flux right now because... Reed working on the quitting system, I think a lot of, or not a lot of, but some of Reed's logic, I think, in his quitter is going to be broken out into pieces. Mm-hmm. And I think, and I put this on the wiki on his page, you might want to check it out, is the user interface should be responsible for that.
Yeah. Right
now, he has like a saving state type of mechanism in there. And I think the GUI should not be responsible for saving state, but it should be responsible for requesting a save state, waiting for it coming back, and then finally quitting. Yeah. So you'll have to integrate that in.
Yeah, I don't know. I couldn't think of it. When I was
it's good enough for now. The only problem is that will kill a bunch of
stuff that we
running
want.
Stuff. So, but it is a sure way to quit because a lot of these things, especially with like all the Juxta additional like threads that it runs and stuff like that. Sometimes those don't quit out nicely.
Do you want me to go over Worker at all?
Yeah, actually, I haven't looked at any of that. So.
What have you done in Worker?
Worker's different.
I never saw it. So I don't know.
He's a different guy now. He's a new man. He's a man among men. Like that. Glad you decided to grace us with your presence. You just missed the most beautiful presentation.
Oh, we had a very...
you changed Worker after.
We had an enlightening discussion on the console.
What's different? What did you change to Worker? More states it? We've changed it? New signal.
I can catch you up on this.
Oh,
mostly some system out lines and some new lines.
Yeah, pretty much. These two guys? Okay.
The wiki / P2P wiki.
Alright, cool. Alright, Worker really what it does didn't change, but we just added the save state. So, whenever the quit signal goes out and parameter sweep grabs it.
Can't see.
Better?
You can sit over there, like on the other side of this thing. Like you know where I sit? Where you guys can see? Yeah, and then you can kind of turn to the right, utilize the screen here, if you want.
Oh, okay.
And then you can use this device,
what do you call mouse
device,
this mice,
and the keyboard device there. But you stay to the right of the text. We're interested in.
All right.
So
So where were we?
So
Oh,
what's new?
Oh, this guy. Down here. The save state stuff. It'll
Okay.
just when it catches the save signal, something along the lines of that. It just also it has one member, private member, working it. Before it would just take it as an argument, work on it, and pass it along. It didn't really hold it.
Right.
But now to save, it does hold it. So I would just save that guy. So, but I'm not sure yet if when the save signal comes, does that interrupt work? Like if he's working, it won't.
Although no,
Because-
you're your own thread.
Because I was thinking if it doesn't interrupt work, then we're not going to have to save worker at all. Because if it doesn't interrupt it, it'll emit the result unit, and what's the point of saving it if we already emit the result unit?
Basically, these objects work even before we went to another thread. The objects essentially are. There's no way to get it to run two methods at the same time.
Yeah.
Because even if you get a signal, you don't get the signal until the event queue processes it.
Yeah.
So until you process the catch, you're not running anything else. So, worker may be fine as a transient object. Now, just to throw a little monkey in your wrench, I recommend you do state saving completely different. You got the wiki up there? No, mainly from the standpoint that I think you should have the application launcher save state. But if it makes you feel any better, all of the logic that you put into the individual objects, you just put that into the serialization routines of the object itself. But worker worker might be transient.
I was
About what?
about whether or not we should save.
Yeah, I mean, we don't need to. If it isn't going to interrupt work,
If
What's the point?
worker doesn't have any state in and of itself. Now the thing is you need. I'd recommend walking through the corner cases, and I think this will require really, really thinking about how pace processes events. But what are your scenarios for a save state situation in parameter suite
Save before it starts.
before it starts?
Before it factor events.
No, in regards to worker, what are the different states worker could be in? And feel free to use the whiteboard while we discuss this. Okay. So, what are the different kind of times that that? What are the states? What does worker look like at various times in application?
Be working.
What does that mean?
doing this.
Okay. So, what does that mean? Tell me what's going on around worker
All right, so
to get to there.
we get an event
All right. So we got an event from where?
from the input factory.
Okay.
The
What did
factory,
it give us?
It gave us a work unit.
A work unit. Okay.
So right here, we passed it, blah blah blah. We did the parameters,
Right.
do the work, which is just adding.
Okay. We've already run into a problem right here. Okay.
Okay.
Input factory not only generated a work unit, but it absolved itself of all responsibility for that work unit. So, at this point, working, who's responsible for the work unit?
Worker.
Right. So we just eliminated worker as a transient. Because if it were transient, what would happen?
Lose the work object.
That one work unit will be gone.
Yeah.
Okay? So you will need to save work unit.
All right.
Okay, now, that doesn't finish up everything though. Okay, so, we've received a work unit. We might want to make notes in the working state, we're responsible for the work unit. You might want to note that on the whiteboard. It's like remote control class. Here we go. So, next to working,
Notes. Working.
or you could just put a little dash response, holding work unit. There we go. Alright. responsible for serialization of that at that point. So, what other states do we have?
Doesn't have any work.
Not working.
Okay, so what has happened to get to not working? When does not working occur?
When I emit work.
Result unit. Okay, so that's a state change right there. Is that emit? Because the second we create that event, the result unit itself now just made it so we're not responsible for the work unit anymore. So you can go like on the board, like next to emit, say, hey, we changed state here. Yeah.
I can't really see that one.
This is changing state to not working, right? Yeah. That's a good place right there. Okay, so are there any other, and there's no other slots that we need to worry about, right?
That's it.
So, before we've changed state to working, see, we run into a problem of atomicity of the event. Atomicity, everyone?
Keep it.
As one operation. Atomicity is keeping a number of operations as one operation. It's done atomically. One step. Where is our atomicity issue? No. Because we can actually control that.
It's halfway through work.
What's that?
It's somewhat through work.
Halfway through work is fine, because if by saying that when we change state to working, we're responsible for the work unit. When we change state not working, we're not responsible. That actually does make it all atomic. That everything in between there is atomic. What do I mean by that? Right. So our atomicity issue is the period of time when we decrement, when we remove responsibility from the input factory, and we begin responsibility of the work unit.
Here. To here. If that's
Actually, no. Further down from the not working. Not in this object.
Oh, okay.
So from when we switch to not working, we're fine. That's a different atomicity. What's the atomicity issue there? When we switch to not working. We have the same thing in regards to consolidator, right? Between the time when we emit that result unit and consolidator receives it, we're broke, right? We need to either ensure that we save the event, right? Or roll back one of the others, right? We either need to make sure we complete the event in consolidator or complete this event in worker, or we roll back the event in the previous object, or we save the signal.
So we want to make sure the consolidator got it.
We either want to make sure it got it, or we save the event in progress.
Okay.
It's easier to say.
That's what you want to serialize the actual policy.
The whole everything, yeah. Because we can serialize the event queues. I still think we need to make sure that I almost want to. I don't know, maybe it's some sort of policy. We might want to make state explicitly part of the abstract modules. You know what I'm saying? State in a very simple sense of basically making certain operations atomic, like making critical sections available. Critical sections are things that you need to occur together or not at all, right? So some sort of, I don't know. But since we wait, for the most part, like when we're trying to quit, it's somewhat safe. But okay, but this is two different states, right?
Yeah.
They're relatively safe, and it's just a matter of whether or not we have anything to save, right? So as soon as we create that result unit, we should probably, null out our work unit that we're holding. Is there anything else to save about a worker?
Result unit. Maybe.
We're not responsible for it. Once we emit it,
It's done.
it's gone. But that would imply that we need to be atomic from the creation of the result unit, right before creation of the result unit, to after the emit. So we probably need some sort of critical section type thing, or synchronized, I think synchronized would probably handle it. Synchronized creates.
So right after this emit, make a critical section.
No. Yeah,
Right before-
that's where it ends. Right after emit is where it ends,
So yeah,
but
right,
before result unit.
right here.
Down. Yeah, from there to there. No, to the emit. There you go. So that's critical. Right? All of that has to happen at once because inside there will also be what? Wiping out the work unit that we're holding. And basically everything from the I don't know, catch is kind of involved in this atomic type of idea.
Yeah, I gotta fix that. I can't just do it. So I want to know what's going on.
Yeah. So, I mean, you look into, again, depending on the state saving and stuff, if we're going to serialize the objects, serialize the whole object, then you just need to kind of rethink of all the logic that you put in the save state, you want to move that into the, the write object, read object method. So, Pace comes to you and says, hey, I'm serializing you. You go through and say, I'm in a state where I need to save the work unit, or I'm not in the state where I need to save the work unit. You need to make sure that, and really just having the data member work unit in there, and it being null when you're in a state when you don't need to save it is fine.
Yeah, 'cause you just
And you actually don't need to, you still don't need to write a serialization routine. As long as work unit's serializable, which it is, correct?
yeah. Totally.
Yeah. I think it'll simplify it. And I think moving a lot of the event catching into application launcher will at least make it a little more manageable. Plus, application launcher already has awareness of all the applications, and those in turn have. So yeah, I think I'd chain it. I have application launcher requests save state from the applications. Well, kind of like what you're doing now, where it propagates through. But the application itself actually would probably save state for the whole thing, and then have work unit kind of save state for. Have application launcher kind of save state for the applications. So then you end up having everything saved. All right. Fantastic.
Of course, it's me.
So we've had So we got some system out print lines
Uh huh.
and some reline, right?
Yep.
We got some of that.
Pretty big progress,
Yeah. We did some stuff.
Something.
Don't worry, I don't expect much from me.
Especially me, because I'm not even signed up for this class right.
All right, who's up next?
Okay.
Ouch. Any comments?
Questions, concerns?
Any comments? Questions? Anything?
Nothing.
Anecdotes? Criticisms?
Where am I? I'm not here. Am I? Alright. Well, I was working on.
Hold on. Phone call.
Alright. Attic. Perimeter sweep. How do I get the pace?
Oh, go to local repository at the top.
Oh, jeez, that's. Local repository. Alright. And paste juxta. Here we go. Alright. No, I still don't see anything. Paste juxta. Age 21 minutes. Alright. This is kind of what I start working on as file manager, and a lot of it.
Oh, hit the markup.
The what?
Tick markup. On 1.7.
Mark up.
Down a little bit. Next to 1.7.
Oh, here we go. Right here?
No, hit markup.
Okay. Alright. Hold on a second. You turn this thing off. Alright. Now.
Oh, erase some of that. This is word. Notes.
Alright. I started on File Manager, and I think this week actually made some progress. But I still hard coded some of the stuff like the directory structure and stuff. I haven't gotten a chance to. I was basically working with Juxta and trying to get like the query stuff. So the file manager itself has a couple of. It receives request file. Request file is when somebody at one of the other applications locally wanted the file. Then they'll
Okay,
send.
so an application, like for example, if I were loading an app and I need the jar,
Yeah.
I'd send a request file.
Uh-huh.
Okay, and we'll see what that's holding when we get down to slot find
Yeah.
file.
Yeah. And then add file is when there's a you get a new application. I guess maybe if somebody just gives it to you, or maybe I don't know. Maybe it
So
might
this will
work.
probably come from the user interface.
Yeah.
The add file will be something like you have the GUI and you say, I got a jar new project, and the jar is from the local file system.
Yeah. Or it might be it might work with the other. It's not coming from somewhere else too. I don't think so.
Like where? Oh, like from
Another.
an app.
Yeah, but I don't think so. I think that's I have to look at it. And then when I started getting into this and I started looking at the pipes and stuff, I realized that it was like pipes didn't really work good. So I wanted to use the query resolver with Juxta. So then I got into that and I was like, well, then trying to figure out how I wanted to do that in Pace. So basically, how do I create some other ones? Because I kind of want to go to the queries first before I get to the files. So, oh, I can look at this, can I? Alright. So.
Actually, do you like the query system in Juxta? I mean, it's a useful system.
Yeah.
All right. Because what I'm thinking is we might add in query primitives. In other words, extend remotable event to also have a query type event. Because I've seen at least in cluster, and then there's definitely places in parameter sweep as well, that a query system would be a tremendous advantage. Because right now you have to create full-blown remotable events that go out, come back. You have to build in your own timeout system and all kinds of other just really kludgy things, where using a built-in query system or having a query type primitive would help. So I mean this query and query handler and stuff, I think wrapping that with query primitives might be okay. So we can integrate some of that probably deeper.
Because I don't know how, the comments are bad, but I don't know how much we can use what I did, but it was getting kind of late last night.
Hit the 1.1. That should take you directly to the text.
Oh, wow. Alright. So here, this is just basically, Juxta has two types of messages, a query resolver message and a query response message. And so I kind of just wrapped that because I knew I didn't want, our application pace to be handling those exactly. And then as I came along, I found some things that like it didn't do that it needed to be, wrapped anyway. Like here, like when I want to send like type, you can only send a string. So here, I broke it up, and so basically, if you want to create a query now, or I mean anybody can do it, is that you just create one of these query objects. Set you have to give it an ID, you give it a type, you give it the group you want to query. You can query any of the groups, and right now, I think it should probably take a peer group info, but right now it takes the pace group.
Okay.
And you just set the group, and then you set the value. And
now, when you say type and value, what are you talking about there?
All right. Well, with type, like I kind of just created the type as a string. So like for mine, for file manager, the query is a string, the type is a string. I was like paste file query. So that way, basically, it sends out the query to the whole group, and anybody who has this slot, I think query received or something like that. Yeah, they're pretty much a query listener. They can look at it. They say, oh, if this is my type, then I'll work on it. And pretty much every query has an ID, so pretty much you can store your ID, and then if it'll broadcast pretty much to the group. You got a query that says, oh, it's my type, then it can check it's my ID, then it can do something, and then it can actually send back to the query handler a response saying, yeah, I found it, and then the query handler will, it's another remote. I think it's another event.
Now, are you just encoding the type and the query into a string?
Yeah.
Okay, so because the query and response system only takes just like can you is it just one string or can you have tag strings?
No, just one string.
Okay, so you have to basically encode all the pieces into a string and then okay.
And that's what I did here is where well this is an older version I think because I ran into problems because I'm passing the URN. And I ran into problems is that there's a colon in the URN.
Right.
So
parsing it back out.
So I switched it to semicolon. And then pipe does some funny things too when you do use pipe. Does pipe have a special meaning?
Pipe is hilarious. But what now? Like the pipe symbol?
Yeah.
I don't know if the URNs have pipes in them.
No. String, like the splitter. If you do like a split with the pipe, like it just went crazy. Just start splitting everywhere.
If you use the symbol
pipe
when you like run a string,
like if you have a string, like if you have
split,
like a delimited string with pipes, and you do split, it doesn't split right. So anyway, I use semicolons because it started working.
Unless it's being interpreted as like or something. So
that's probably what it is. I don't know.
You have it in you have it in quotes.
Yeah, I had it in quotes. I don't know what happened. But so basically, and I get around so when you set the query, when you get it, you just do set type and set value, and then I let the query object worry about it.
So you've abstracted away and created like a you have a more rich query object that just turns it into the basic string that you're allowed to.
So you don't have to worry about parsing. What
does
type.
This do the parsing as well of the? In other words, when you receive a string, can I instantiate one of these and break it back down?
The query handler actually does that.
Okay.
So
wait, the query handler does the parsing or does the
parsing?
Oh, okay.
Back into it when it creates one. Query response is the same thing. It's a little bit different. I kind of want these two to be the same objects or be wrapped or something, but I didn't really have time. But query response
I think your parsing should also probably go back into paste query. Let me see what it looks like.
Yeah, it probably should be.
Because I have a feeling that's going to change. Like what we parse out and stuff. So.
Yeah, it was really like.
This is a good start. This is a good start for. Because I think we can basically take what you've done with the paste query object and turn that into like some of the basics of our primitive.
Yeah, that's why I just went on and started doing it because I figured we need it more. All right, and then this is the query handler. It has 2 slots: send query and load query handler. And it sends out query received and query response. So when somebody wants to send query, they just emit the signal send query, and it runs this slot send query. Just takes the What is this?
Also, just a quick note. Notice Richard's using the new style of debugging. So that's been rolled into abstract modules. So use it whenever you, any output you do, I'd recommend doing that. For now, some of the testing, it's cool if you do some printing, but in the end game, we want no output at all from any object.
Yeah. I thought I fixed it. And you're like, we talked about it, I already fixed it. And I was like, I already fixed it. And I realized that
Okay. I'd like to officially give the glory of the debugging stuff to Nick, because it was a simultaneous discovery, and I think he deferred to me just because,
like calculus, two guys.
Yeah, they both discovered it. So I'd like to officially, I'm going to officially just, I don't want any of the credit. So what I'm saying is, okay, even though it says it's my name on the check-in, I want to say that Nick
pretty much
gets credit for it, okay?
Okay.
Now,
It's kind of cool with Visual Studios. If you do a debug dot whatever, the compiler automatically takes out all your debugs when you compile it for release. That's kind of cool. So you don't it even takes the extra code out.
oh, it
when it
does.
compiles it, for Visual Studio.
Even in Java?
No,
Like in C?
Yeah,
Are you
C
thinking
sharp.
like if devs?
C sharp.
Oh, shit. Like
C
C sharp?
Yeah.
Oh, okay.
So that's kind of cool, but totally unrelated. And then when it gets your query, it has a group. You have
We'll
to.
take advantage of that when you port it to C paste to C sharp.
But it has a group. So I think you grab the group from the query because you can query different groups, and then basically it just sends out the query to the group, and that's really doesn't do much.
This tying to the group, what I'd recommend is modeling on the current pipe handler, where the pipe handlers, the regular pipe handlers, the object pipe handlers, we're spawning a new one for every group. So they'll have their own loop and everything, and they'll have their own basically instances of the handlers. That way you can take out all that looking for which group is which.
Okay.
You see what I'm saying?
You're saying having multiple handlers for each group. Each group has its own.
Each
handler.
group has a handler and
Okay.
a sender, receiver, or whatever for the queries.
I actually like that.
Yeah, because what ended up happening is, first of all, they can process their own discovery events and everything, or like listening events, so they have their own thread. But then, in addition to that, you don't have to worry about filtering and everything, because they'll end up. What you can basically do is you just look at the event and say, "Is this my group?" Oh, okay, it is. I'm going to continue.
I think that'll help too, because I'm also worried about too much traffic hitting them.
Yeah.
If there's one, and there's also like a little section where I have to block. And so, but I think Juxta automatically creates a thread each time it receives a query, so you don't really have to worry about that. But so then once it creates it just sends off the query, and basically this implements anything that it has to implement query handler, and anything that implements query handler. This is where it has to implement this process response, and it has to implement process query. Process query is when you get a query, and then you have the option to either, handle the query, or you can repropagate it. So basically what I do, I don't know, actually this is like where I was kind of torn, was if I get a query, I parse it here. Basically, which probably would be better inside the case query. And then it emits the query receive group, and anybody who has it has that slot query receive can look at it, see if it's their type, and check to see whether they want it or not. And here, this is where I just wait, and I purposely want this to wait until. And the queries also something else I also added to the query response is has it been processed? It's just a Boolean, and was it found or not? So once it's the response is processed, then it continues on, and it does something. Oh, if it finds it, then if they whatever the query, whatever you're querying, if it's found, because the response also has a Boolean for found. If it finds it, it sends back a response, and if not, it just repropagates the query. And
that probably only works because of the new threading. That wait 3000.
No.
It worked before.
I haven't updated it in a long time.
You don't have the new pace?
No. But I think it works because it's on one of those Juxta threads that spawns. I don't know. That actually works though.
I'm just trying to think where the event would go. Because it's other objects. Well, I mean, the main thing is that you're basically directly going to the response object. So as long as the thing that's responding is not in Juxta, actually, anything that's not in Juxta can respond because it can process the.
Yeah, and it'll actually I think Juxta stuff can process it too. Because I've got I kept
I don't know
hitting.
what thread would do it.
I kept hitting F5, and it kept on. So I had 3 running simultaneously. So I think it's running somehow. It's running on a different thread each one.
No, what I'm saying is file manager file manager processes one of these, right? I just don't know what thread would run it because the thing is anything that you say emit with, that thread, it can't be a Juxta thread because the Juxta doesn't know anything about that. You know, it doesn't know anything about these signals.
It works. I was happy. I don't ask if it works. I'm not going to ask why it's working.
I mean, I'm curious as to what thread is processing. But and then because during the wait, you'd wait.
And I actually need to put a timeout so that it only waits a certain amount of time because it's.
See, I think I'd break that out so that you do the emit, and then you have a separate. So look at some of the other. Who's doing a?
Quitter and input factory.
Yeah, quitter and input factory. You'll see the kind of pattern for handling a timeout as well as. Yeah, he's gonna do something with it. So
I actually did that in File Manager.
In File Manager?
Yeah.
Okay, I'd use a similar pattern there. I think the only difficult part is that
you're
doing this so you can keep the query, right?
The reason that I had to do it this way is so that I can repropagate it out if I need to stay.
No, just hold it in the response in the payload. In other words, whatever you need for the second half of it, keep it in the payload of the signal. So that response,
so then
you might need to pack more in.
Yeah, I'd have
whatever
to
you
put some
need
other
at
stuff
the end.
in it. So yeah,
outside the object data.
So I could put I could put what do I need? The resolver and the stuff.
Well, the resolver you can still get
from the group.
You can still do that because that's from the object info. I mean the object we're running in.
And the response message I have to keep.
The response is the only thing you work on, right?
Yeah.
Yeah. So the same signal. It's just process the signal
somewhere else
when it comes back.
Okay. Yeah. That would actually work.
See, I think doing this, encapsulating basically really doing encapsulation where we're not using these backdoors of the response variable, the object itself, just keeping a pointer to it and then working through that. By encapsulating them and leaving, we really can get asynchronous, and we can start running, maybe running multiple instances of these things. Who knows? I don't know yet, but
okay, I got you.
We want to keep everything as sealed as possible, so we can just start going crazy with where we send signals and processing signals, stuff like that.
Yeah, that might actually work. I was trying to figure this out last night too.
No, this is a good model. We can definitely roll this into I think even a more fundamental primitive of pace, not only just in Juxta. So I think.
Within pace. I get what you're saying now. Yeah. And then what else did I do? File Manager. Now, with File Manager, it's really bloated, and then it's gonna break it up with general group stuff. But I didn't have time, and it was already working. Mm-hmm. So I didn't. So I was because. What I think pace peer group only creates pace groups, and so I needed.
Yeah, that one, and we really need to think about whether we want.
I mean, if not,
how we want file handling to work. But I think a file group that's kind of a either kind of a super child a stepchild of PACE that's outside
Mhm.
the rest of the PACE groups, or a sibling group to PACE. In other words, you have PACE, which represents all your application groups, and then you have PACE files or something, which is like a sibling group, which just represents file transfers. Because really, it is a separate
Yeah.
service in the sense that you have these files over here, but PACE doesn't really deal with files. PACE deals with, objects and stuff like that, and methods and everything. So I mean, it's like, and having signaling between them is a way of saying, okay, I need stuff from this file because even though we like objects and stuff, they eventually find their way into a jar or something like that. So we can go get it, but then we'll instantiate it, and then from there on out we can leave the files alone. And I mean, it also opens the door to not participating in the file transfer types of systems where any file that you have, you can just say, okay, here's a different module rather than the file manager that is only doing local files. So you can't participate in any PACE thing where you have to download files, where you actually have to preload them or something. I don't know. But I think a sibling group, like something that's a direct sibling to PACE,
Okay.
where you have your own group of PACE files or something.
I think that's what it is now.
Okay.
It creates a sibling. Yeah. Yeah, it's a sibling.
Directly
PACE.
across from PACE.
Yeah, that's a sibling PACE right now. So that's why I got a lot of like juxta group stuff in here.
Mm-hmm.
But basically, to get it started, it receives start file manager,
Okay.
and it pretty much because I needed the net group to get the juxta stuff going.
Okay.
And it takes all the juxta stuff, creates the peer group.
Wait, when you say the net, that's working off of the juxta, the juxta launcher.
Yeah.
That
I
net
think Juxta Launcher actually I added it to send out.
the start file manager.
Yeah.
Okay.
Yeah, so Juxta Launcher starts file manager. That's something else I wasn't sure about where to put that at.
Yeah, I mean that's a good thing. Or in fact, like, what do you need off that? You need
I just need the net group.
the net group. I think what's it called? PACE peer group also needs that.
Mm-hmm.
So I think just making a more generic signal of here's the net group, and then
Actually, yeah, right next to each other. That's where I put the Juxta one. I didn't want to
Okay.
mess with it. But yeah, probably just one.
yeah, one generic signal that says here's the net peer group, and then anything that needs it can grab it.
So I get that. I create my Juxta advertisements. Look for it in cache. If it's not found in cache, then pretty much the same thing you do to create a group. So we've seen that already. Once the query handler. Oh, okay. Now if somebody requests a file, I guess I'll do request file first. Which one is that? Slot find file. Slot find file. Slot find file. Local find. I think I passed it. Slot query file. Did I write that method yet?
Scrolling and it's not there.
Alright, let's do slot find. Ah.
There we go.
Alright. So basically I have a hash table that keeps up with the file objects. You know, if you already have it on there, then I just keep the file objects in cache. And I think is that what happens? Alright, yeah. Well, at least that's what I've meant for it to happen.
Alright.
And okay, file found. Okay, all right, yeah. So basically, it calls this group local find file. And where does local? It's a private group, private method. See, that's why this is way too big. It takes me forever to find stuff in here. Next. All right, local find file. Here we go. And first it checks the cache file, which is just the hash table with the file name and the file object. If it finds it, then it returns it to the, because that should be alright, right? I can pass the file object to something else within this computer, and it could use it, right?
Wait, what now?
Like I can just pull the file object out and send it, and then
Give the file
Yeah.
object itself.
okay. And if it doesn't find the file, this is gonna go away. With just hard coding
Right.
directly.
I hope that goes away. I don't have a C:" drive, so.
But this is yeah. that's gonna go away. That was just for me testing.
Okay. So if it finds it locally, it'll pass that file. Otherwise,
It
I thought
does
the
a
next one
query.
was a file query.
Yeah. Well, first, then it checks the. I think then it checks the cache, then it checks the directory where files are. And then,
That's not the same thing.
no, I keep a file I don't go load all of them. If you happen to add one or it happens to load it, I keep it in cache. But if it doesn't have it in that cache, then it searches the
Okay.
directory.
So there's
to
like
find
a look aside book, a cache. So you go check your hash table.
Yeah.
If it's not in there, that's the only time you start querying the file system.
Yeah.
Okay.
And then if I don't find it in the file system, then I return null, which then shoots off the file query. And eventually it gets here.
Okay, and then that goes through your other objects, your
Yeah.
other.
Well,
systems.
this goes here, and I don't know. This is something where I might creating the IDs for my query. Right now, I just create a random ID and then I store it in the hash table. The query that I created, so that I can get it back. I don't know if there was think of a better way, and also I check to make sure it's not a duplicate one that I created.
All right.
But I can still run into problems where, well, it shouldn't be another file manager with the same. We're not running multiple instances of
the
this.
file manager.
Yeah, so I guess I won't run into problems with that.
I think some of that will be resolved by having the multiple queryers. Oh no, actually, this only has one query, right?
Yeah.
The file manager query.
Uh-huh.
I mean, timestamp would be good too. I mean,
Yeah.
you know,
Timestamp.
timestamp and file name or something like that.
Well, it's got to be ID. It's got to be an int.
What's that?
It's got to be an integer.
No, I mean anything hashed
Yeah.
to the ID.
Oh yeah.
What I'm saying
Never
is just
mind. Yeah.
is to keep it progressing. I mean, as far as
Yeah, I just need to figure something out. Some of the stuff I was just doing quick, and then pretty much it just does send query, and then we're back to the
and then
query.
you get it back, and then
Oh yeah, once I get it back, if it's found, yeah, it actually does some more stuff. If it's found and it comes back, it checks to see if it's a file query, and then if it is, I think it checks its cache or somewhere. Yeah, if file is not equal no, then it checks to see if it has a file response. Oh no, this is different. This is if a query is received. It checks to see if it's a file type. If it is, then it checks to see if it has a file, and then it returns a query response. Come up here. This
is found. This is
this is
queried on the Juxta network. And
oh no. This one is if somebody else queried.
Yeah, no, the one above that,
Yeah.
the found.
Yeah, this is if I queried, somebody found it, and it came back. And here, what I do is I create a pipe, an input pipe, and then I check to see if it's the query that I sent out, if it's one of the queries I sent out, and then I get the file name. I create a pipe with that file name, and then I send my ID, my Juxta ID, to that peer through a query. And if they get a file request, because I have two types, a file query and a file request, and a file request means I already know you got the file, so you just give me the file. I send the peer ID to that person, of the pipe that I have, and they just create another pipe.
Let me see what you're creating here. You're creating an input pipe. Name is what?
Name doesn't matter, because I'm not using this search stuff. But the name is the name of the file, I think. Where is it? Create input file. Where's the pipe ID? It's the name of the file. Yeah. The name of the pipe is the name of the file.
I mean, can we go ahead and, when we send a query, hey, I need the file, they're sending back, do you do it? What is your handshake steps? You say, hey, I want a file.
I say
you choose one that you want to receive.
Well, now it's the first one that's coming back.
Well, yeah, but you choose one that you want to receive.
Uh-huh.
And then you set up the input pipe.
And then I say, give me this file.
And then what do you send back out?
They send the
And
file
actually
back.
using a query again.
Yeah, I send alright, say, because you can send queries directly to a peer.
Right.
So it's sending a query directly. Well, actually, no, it doesn't. Actually, I need to fix that. Probably right now, but it should send a query directly back to that peer with the pipe ID.
Uh-huh.
And then that peer will be able to create a pipe, mimic that pipe ID and send output back to it. And then this stuff, there's like a small bug with the query thing that I did, so it's not working. But I have, this is my group listener, but I just created like a file input listener that sits here. All this stuff works because I didn't do it. I already tested, and then this is just sends the output message.
Okay,
That's how
so
you do it.
go down to the one that receives the file.
Alright.
Okay, then you just write that to your little directory,
And-
and then you pop it in your cache,
Uh huh.
and then now.
Well, I need to send out a signal too.
Okay, so then you signal
Yeah.
that it's found now.
Yeah, found file. It's just the same thing that would emit if it was found locally. And that's pretty much what I've got. There's down at the end. There's a couple of problems, but not.
Okay,
anything really.
looks good. Looks real good.
Any questions?
Alrighty. Go on.
Alright. Well, I wasn't going to talk about what I did, but since that seems kind of old, we're going to have to change it anyway. Just talk about, briefly go over what I did, and then talk about what we're going to change. Alright, I want to go pace.
Would you get started with Twitter?
Yeah, I'm stuck with Twitter. Okay. Essentially, I took out all the weights and did the just added a bunch of stuff for the poll saves and just the polling, really. What happens is it sends out a request for the list of loaded groups. Takes that right there. If it's empty, it just says quit because there's nothing to save. Otherwise, sends out. Oh yeah, I hit some problems. Like UI, I think was a problem for some reason, so I just removed it, and so it won't.
So it doesn't participate in the.
Right, it won't participate in the quit at all. Or actually, I don't think it was sending back
Any signal.
any signal to me because the the UI closes. You hit the X button.
Actually, in the GUI, it's set to high. It actually doesn't.
I wasn't getting a signal back, which was my problem. So I was thinking it was just closing before I ever got the chance to send anything out.
Because if you hit the X,
Mhm.
if you hit X, it hides the window. The default is, or it does deconstruct the window itself, but the object, the
Should still be
object
loaded.
itself is still there processing. Now, if you hit quit, like from the
You know, just kill it.
like quit the app type thing, that does something different, which is worse because it doesn't process it. So I mean, we need to clean up how we do our UIs, but it might have been that. That's
Yeah.
why it seems to be going away.
I figured there's still a lot of work to do with it anyway, so
Yeah.
I just fix it so it works now, and we'll go back and fix it later.
Okay, so that's just to get it out
Right.
of the way for the rest of the module.
I wasn't getting the signal, basically. And just sends out a save because save just dropped a paste and paste sends it to everybody. And I was basically just thinking if anybody needs to save, they can have their save stuff. If anybody doesn't need to save, they can just have a little, I'm saved. Send it
Okay,
back.
so they just sent a null save.
Basically, yeah.
Okay. One thing that we might want to do there is add a null save processing to abstract module.
Okay.
See, the main thing is this: is I don't want to have to leave it to a programmer to put in an empty save. Otherwise, we have to wait for the complete timeout.
Right.
You know what I'm saying? So I think having a null one in there where they have to explicitly get around it would be better.
And just make them have to override
It's
it.
basically like an auto slot in abstract module, and I think we need to look into that. As our signaling and we have a lot more standard signals and stuff like that, we might want to start adding in more default handlers for for some of these signals. But I think that would clean up a lot of stuff where if you don't know about the functionality, then you can't use it. So you might as well just admit I'm saved or something like that.
So that was more on the spot.
So then you do your delayed event.
Right.
It comes back.
This just sets up the polling delay and fires out. Update handles whenever something has saved or returns verification, and it just adds it to the list. Another problem I ran into was the application actually being named parameter sweep, because I'm pulling the name from where we load the jar. Like right now it's CSC 4999 parameter sweep, and parameter sweep was after I returned a string. So what I was doing was seeing if just a substring anywhere in the big name was listed, but if you change the name, it doesn't work.
Right. So
I wasn't sure where the best place to pull the name was, or pull the name from.
okay, what is it we need to know the name for? Is that so that we can keep doing the tracking of who saved?
Just who saved that, yeah.
Why are we not enumerating through the group model?
I do.
Where?
Oh, when I get the apps. When I get the apps, they're just named. They're just named like they are main. Like
So
where is that?
it's their standard name.
Oops. Like UI has UI, Juxta has Juxta.
No, I mean the group model as far as like the all the groups that are loaded, like all the applications we're running.
Right.
Those are fixed. UI and Juxta right now are fixed. So I mean, finding those is go directly to them. But the other ones,
The group model returns the name CSC 4999 parameter sweep, the one you load, the one you enter.
right? Okay, so the name that you tagged it with,
Is
that's
what
what it's returned. Wait, all I'm saying, what I'm saying is getting the root paste group and then enumerating to the children and watching them. Why are we doing a separate apps thing?
That's just the. I was using that to verify who was who, like whether or not they had saved. Or actually, let me show you where I get it from. That's this list.
Okay. Oh, list group. Okay. Why can't I mean? Is direct comparison not by name not working? In other words, if you say, okay, I'd save, what's the payload of that?
It's when I do that, it's a string. If I do it out of input factory, it's just a string. So when in Juxta launcher, under Juxta, I've just got a fake save that sends back I've saved with Juxta as a string, which matches the Juxta name.
Just because, like for example, input factory won't know its name.
Right. That was my big point for today.
But could you not do it by even if we're gonna change things, I don't think about it. But what I'm saying is, I don't think it would be bad to for example, give them their group when you're instantiating them. So here's your group, and then being able to compare on group as opposed to a string. The group object itself. In other words, if group equals. You have a list of all the groups. You have a signal coming back with a group object and a payload. Just do a direct comparison of the objects.
All right.
instead of any strings.
Okay.
Because they all have the same view of the objects in memory. I mean,
Right.
being able to doing direct pointer comparison is
Just pointers.
legit. I'm just saying something definitive as opposed
Yeah.
to.
Well, there's definitely a better way to do that. What I'm doing.
Alright.
So we'll change that. Other than that, and the signal catching and pointer, yeah, this is just the timeout control. It
Right.
sets a delay, waits for up to 10 seconds. This is just the hard quit. You told me you wanted me to move the GUI stuff into the GUI, but this says, like, if anything hasn't saved and you still want to quit, you just don't want to wait any more time, it'll actually just go ahead and send out the quit signal to everything and just shut down.
Okay. Alright, so have you given any thought of moving that out into a separate kind of?
Yeah, well,
tree?
I'm thinking that is just going to be its own little class with just a signal to trigger in the GUI. And most of this quit stuff, since you want to move it all to the application launcher anyway, we can move that. Or
We'll still need the.
we can move everything that pertains to the saving to the application launcher, and then kind of like just cut out half of the saving stuff and move it there, and then have quit still maintain its quit state and everything.
Wait, what now?
Like for everything that causes a save to go out, move that to the application launcher. So when we save, we'll
Okay,
save
but
everything.
who's gonna be admitting it?
It's all still like you're gonna have a state safe signal, right?
Right.
Probably from a GUI or over time. So whatever that is,
Periodic, probably.
yeah, whatever that is, it's gonna fire out, and that's gonna go to the application launcher. Quitter also will still be able to send that. It'll just send it to the application launcher instead of handling it itself. Right. That seems logical.
Alright, if I'm the GUI, or I'm a user interface, I'm about to quit. Right, the user has indicated to me in some way that they want to quit. So I will, probably say.
Then
Save.
you'll probably go ahead and do the request quit setup.
Wait, request what?
Like we'll probably go ahead and do it with it now. Like how it handles it now.
No. But what I'm saying is we should receive the timeout instead now. Because see, the pop-up of saying the idea of quitting without saving,
Mhm.
I think is an interface question. I mean, that's something that needs to be handled by the interface.
Okay.
Because you have to have interfaces that are able to just disregard that question, like a console or a daemon or something that like an auto running or something, right? It
Right.
needs to be able to just say quit, done. There's not going to be a user here to verify anything or anything like that. So I think the idea is you send out a save request, and the only thing that the quitter and the combination of quitter and application launcher should handle that save request.
Okay.
And I think that the GUI should be responsible for deciding how it's going to wait for a response of everybody's saved. But I still think you're responsible for having the knowledge of everyone is saved.
Right.
So none of the is this one saved, is this one saved, is this one saved should go back to the GUI. So you're still responsible for all that. The only difference is the only thing you can send out is I'm done. I'm done saving everybody. And then I think that the GUI or the user interface of some sort is responsible for sending out the delayed event that says timeout. I haven't gotten a response yet. I'm quitting anyway, or I'm prompting the user whether I should quit anyway, or whatever.
Right.
And then there should be a second signal which is quit. And quit is quit.
Quit means done.
None of this stuff, none of this other stuff, it's all tossed out. So the idea is, before you admit quit as a user interface, you should do everything that you have wanted to do up until now because quit is going to quit. and it's going to wipe out everything and whatever. So, I mean, that also opens the door to, because I think that, like for example, in Boink, this other public computing platform, which like SETI at home uses and stuff like that, they have a good system of periodically check. They actually periodically heartbeat a checkpoint, so that you're always saved. So there's no problem in quitting. Quitting will always just roll you back to the last one. So they don't even bother asking for another checkpoint. In other words, you were checkpointing all along, so if I quit, I quit. I'll just go ahead and cut off the power because I know all my states back to the last checkpoint. Okay? Unless you write apps, which a checkpoint is a day, like a day or two ago. If the checkpoint was a day or two ago, then it might move you to ask for another request. But sometimes it's not possible. Sometimes a day is how much stuff is in the state of one calculation. That saving that day's worth of calculation will basically, you might as well start over. I mean, there's a lot of stuff that goes on there. So my options are either throw away a day's worth of work or write 2 gigs worth of information to disk or something. I mean, those are the types of things that can come up in these big calculations. So, but I think that's a user interface question.
Okay.
So I think the primitive. I think getting even more basic as far as what of what operations you're handling. I don't know. I think it should just be. I could save. I can be aware that everyone's saved, and then I can quit. So I think that'll. But I mean, and then also rolling that into the changes as far as saving and serializing. I think you can kind of look at both of them at the same time. But I like the mob, and I noticed that when first of all I was very impressed that everything compiled and ran. So I compiled and ran it, and then I went through and I quit. And I was like, I'm just sitting here. And it sat there for a while, and then it popped up a GUI that said, I couldn't save because your stupid cluster app doesn't have any awareness of the signaling that we've added in. So, so I had to wait for all that to go down. But I think once you get the basic signals down, I think then you can look into, which of those we can roll into abstract modular. As basic things that people can override if they want something else, whether it's
I was thinking maybe we should report back to what hasn't saved.
what's that?
Like we should report which objects haven't saved if they haven't.
Oh, like when you do it. Yeah, and then also, I mean, the other thing we'll need to add in there is, I think one of the things is have kind of a transient flag on modules. We can't tag the object as transient because we're dynamically loading them and all that stuff. But having a transient type flag where you can kind of, I'm a GUI, I'm transient, or whatever. Console is probably transient. Paste GUI might not be. The graphical user interface might not be because you might have settings and whatnot. But chances are it will be transient. I don't know. Because usually if you save settings, you hit OK, save, or whatever. But those are probably transient. Jex does not. Some application like chat is transient. Like the whole application chat is transient. But for the most part, if not not really transient, but in the sense that transient in the sense that you don't write any state, but you do want the object back when you come back up. In other words, like chat. Chat doesn't save any state if it could. Save the log or whatever, your username. But let's say we have an application like chat, some smaller app that's kind of doesn't have really a state to save. It's kind of maybe it's an informational thing, it's an alert type of thing or whatever, right? So it doesn't have any state that needs to save. It's transient in the sense that when the application requests a save, I have nothing to write to disk. But it isn't transient in the sense that when I shut down Paste and I bring it back up, I want this app running. Right? Transient usually means you just toss it out, but there is still a member there. It's just when you initialize, there's nothing to put into that member there. So I think we need some sort of mechanism like that so that you can kind of, when you're walking through like App Launcher or whatever, say, or the application, saying, I need you to save, I'm going to write your object to a file or whatever, but right before that you're going to say, are you transient? Yes. Okay. I'm skipping you, but I know you're here in some way. It's like I know you're here because when I come back up, when I resume, I need to make one of those objects, otherwise we might run into a problem. Like worker, if we decide worker, in that state between, at that point it is almost transient. I'm not writing it, right? But if we don't instantiate a worker when we come back up, that's bad news because we won't have the bulk of our application there. So, I mean, in some of those cases, you might write something, but there might be some whole applications or some whole modules that are kind of, I guess that's what I mean is applications might be transients, right?
Okay.
Whole application things. But something along those lines because you're going to have, some, when you get to the resume side of most, all your stuff is saving real well right now. When we get to the resume side, there's going to be some sort of thing that goes on in place of application launcher, where you're now the application launcher, but you're an application launcher of applications in progress. So I think we're going to have to add some, we're going to need to add stuff to both application and abstract module. And we have a lot of different scenarios, like at least Juxta, the GUIs and stuff like that to handle. And some of them might be completely transient in the sense that don't even save the application. So like the GUI, you probably won't even save the application in the sense that when you load back up, you'll have your config file that says launch the GUI. So, I don't know. There's going to be some flags and stuff. Some sort of object type for these applications. And I think it's at the application level that we need those. And then also, that's going to also relate to different things with the abstract modules as well. So, but we want to build in as much kind of free functionality for the module developers. Because I tell you what, writing this, like when I started doing this cluster app, it's doing what we want. I mean, it's rapid. I was really it's like I wrote the implementation of the actual clustering stuff real quick, and it's just really us learning the patterns of these application styles and stuff, and like the signals and stuff like that, where I found myself kind of reinventing stuff that we do in Perimeter Suite anyway. So I think we need to find out what those patterns are and put them in, like state saving and stuff like that. We need to see kind of, oh, this is a worker. Workers are usually transient-ish and that they don't store anything, or there's a checkpoint here and a checkpoint there that we need to know. Everything in between is usually just, you don't have to worry about state saving or whatever. We need to find these patterns because when we find these patterns, we'll codify them in default, subclass, the superclass methods and things, so that next time we write an app, something like, okay, I decide I want to go to a linear program. So a linear program is a bunch of different variable inputs, and then it tries all the combinations of them. All right. So I want when we write a linear program, I want to just be writing linear program stuff. And since it follows something that's just like Perimeter Suite, I should be able to not rewrite anything that's the same as Perimeter Suite or clustering or whatever. So that we have that rapid. I wrote this method. I created a data structure to hold my work units. I created a data structure to hold my result units, and I have a completely distributed app because that would be huge. That'd be a huge platform. That would be something that people go. People suck at writing distributed apps. That's just all there is to it. You can write something that they can concentrate on their algorithms, their domain stuff. You got something big enough. So. But what else you got? You got anything else to point out?
Not in Quitter. Input Factory.
Yeah, see
Became
some of the
Halo.
stuff we've done there.
Input Factory really became the guy that handles making sure everybody. I kind of just clutched that in, but
Okay, so he's kind of he was kind of
He's the guy who makes sure everything
make sure everybody's
happens.
safe. I think something like that is. I don't know. We'll see when we start. When we start saving everything. It may, we might not need some of that, but you do need something to kind of find out what the state of
Yeah, like
the app is. But either that, or we need a general system of saving like the signals that are in the queue and stuff. Like what we were talking about. But somebody's gonna have to be responsible for that
somebody
kind of
has
thing.
to make
If
sure.
we can do it in a way that's so generic that we can put it in an application or application launcher, that would be awesome. But if not, knowing something about that, one of them's gonna have to be smart.
Right.
Either that, or even creating like a I don't know, a manager type object, like our Bootstrap, a generic object that's in all the apps that can kind of
Maintain
make the app into a state. You know what I'm saying? Okay, I know that this result unit's in transit. I know that this work unit, this input factor's idle. Yada yada yada, or something. But you do need something like that, I think, for most of the complicated apps, right?
So, I mean, other than that, he acts like he just. It's all about. He just everybody since everybody gets save, everybody goes straight to their save,
Uh-huh.
and let's see. All right, so this catches the save signal, sends save state, and then sets up its polling delay.
Okay.
It's got an update that consolidator sends out. It just sends out strings that say, I've saved, which set the flags to true.
Okay.
And they were set to false before. Polling delay sends out to, where does that go? Down there.
Okay.
So it just says if they've all saved, everything's saved, which is going back to quitter. That's just the string it
So that
sends.
you're done. Okay.
Otherwise, repoll. Send out a new delay.
Yeah, it's a good model. You go out and say it. So he gets the initial thing and then tells everybody to start saving their stuff.
Right.
But they don't report back to Quitter. They report to him, and then he reports back to Quitter.
Right. They send out instead of sending out the app save, they send out object saved.
Right.
Object saved is called by.
Okay. It's a great model. I mean that happens a lot. Is just picking an object and kind of having that be the guy who collects these secondary signals and then does the first one. I mean, I think we run into this a lot, and also this ability to hook in and just. I notice a lot of times, like some of you guys have been creating new signals or renaming signals. Get in the practice of just hooking. Just say, okay, well, I'm gonna instead of you catch, I'm gonna catch it, and then I'm gonna make the secondary signal, but then I'm gonna end up over here making it look like the original signal that was supposed to come out. In other words, like the quit or the request quit or whatever, just kind of
Resend.
put yourself in the middle with a secondary signal and then be done. Because what's neat about it is, I mean, these signals are really, really, the signals are very, very restrictive interfaces. It's like it's a name, a payload, but nothing else is around here. You're not you don't have access to any other variables. This is the interface, period. This one type of object is the interface. It's the only thing you can talk through. And interfaces, like with anything, you can do adapters, you can put stuff in the middle, and you can do gatherers and stuff like that. I mean, there's a lot of stuff that we're doing with this that, I don't know, it's pretty flexible. You can really add in whole new sets of functionality by just plugging in two signals, right? Just changing one end, and the other guy doesn't even know that anything's going on. And I was really impressed with a lot of this stuff, like, we make drastic changes and some of the stuff, but that's been the test for me, is that I can bring in my app that you guys aren't even touching at all and
Still have it
have it integrate. And, and some of the stuff, like, I was really surprised that completely changing the threading model didn't require changes in most of the code. There was one thing, and that was the fact that we're restricted to having to start a thread by using start. And because of that, I had to tweak a little bit in the sense that the GUI needed a dummy start method and just some little things like that. But everything else just went on its way. So I think we're doing some good encapsulation and good object-oriented design here. I mean, we're doing stuff where we're not drastically changing things, and we are, dramatically changing implementation, which is, the purpose of this style of software development. So we're going kind of a level beyond that to component-based software design, and we're getting into these like little modules, and I think you're seeing the power of being able to interface with these very defined interfaces, very, very well defined, very good rich set of, we're getting a richer set of abstract objects to subclass off of, and we're getting all this neat functionality. The fact that, I almost eliminated abstract module in redoing it, because abstract module is actually almost equivalent to event queue. And we're getting to the point where we're reusing these patterns so much that we don't even need as many objects. And event queue is almost indistinguishable. I think it's the only distinction between it is the step from when you process the event. The only real difference is is whether you're invoking a method or running catch signal for a module. So that's the only place where they're different. I think if you look at abstract modules, there's like 10 lines of code in it. That's because it's directly subclassed off of event. So I don't know if it's working. Yeah.
Yeah. One thing I did try to do was have one signal be caught by two functions, two methods.
Should work. Oh, no.
Didn't work.
Two methods?
Yeah, and the same
No,
object. Yeah.
Doesn't work.
Definitely did not work.
We can, and that's one of the major differences between the two, between event queue and abstract module. Is event queue holds lists of things that run catch signal, whereas abstract module holds a single event.
That's why.
Multiple methods. See, there's not a lot of benefit of not running them in serial. And the reason I say that is because even with the new threading module, the new threading model, each object still only has one thread. So even if they're both catching it, they're both going to catch the same signal, they can't run them simultaneously.
Right.
So I think what typically has been emerging is one of them catches it and then emits to the next one. In other words, chaining them rather than in serial rather than parallel. But we can do it. We can swap it to having multiple slots being able to catch the same signal.
It didn't really make much of a difference to me because I just added that extra hop, that extra function that split the signal. I just gave.
Oh, I see. Yeah.
Fired one out and then set my own from that. Because that was what I was trying to do.
Either that, or even without creating another method, you can just put it at the end of the other one.
Yeah.
Just choosing one to run first, and then just putting another signal at the end that goes to the next one. So in other words, if you have something that comes in and something that comes out, like one comes in, and you want two signals to come out of these two different methods, well, have it come into one, have it emitted the signal that you want to come out of it, but then also emit another signal to the other one, and then do it like that. So
I didn't think it was a big problem. I thought it was just something like maybe somebody else ran into it.
When I look at event queue, because you'll notice the difference between event queue and abstract module is this, and most of it's catching, but it's really that method there, that handler down there is invoked directly as opposed to calling a predefined method, and that's really just to handle our dynamic, the fact that we can add in arbitrary slots and handlers, whereas if we did well-defined interfaces like you're used to in Swing, Juxta, and all these things where you have like a implements, so-and-so listener, action listener, whatever, and then you have this action perform, well-defined method. The only reason this is any different is that we don't know what the methods are called, and we have arbitrary numbers of signals going in, and we're loading from a jar, and we're not deriving off the same common, we're doing all this stuff that's just completely dynamic, so we have to go to reflection to just take a name and run it. But it's not much different from event queue. I mean, we're using the same queue processing, loop and everything, and catch signals, emits, all that stuff is all the same in both. So we're getting to the point where we're getting so abstract we might not need to use. It's like all the functionality is kind of in this abstract module or event queue. People can just write a little bit and be done. But I don't know. I think it's turning out good as well, in the fact that we can miss these event queues and they seem to be routing signals and stuff like that.
Hiding errors.
What's that?
Hiding errors.
Which part's hiding errors? Well, the main thing that's hiding errors is reflection. Because reflection can catch most anything, but I'm not.
I mean, now
Most of them are most errors will turn into invocation errors.
Yeah.
Which is this.
Well, it wasn't so bad. Like I started, because what happens is that I never, like before I didn't realize it. Like I would just get that invocation error and I would get nothing else. It would say
You can
like
scroll down.
It would just say 6 more.
What's that?
It would say like 6 more.
No, invocation error you should see in the stack
Yeah.
trace. It should get to the actual error.
There's I don't know a specific thing, but it was like something totally unrelated to that. But now that I'm starting to get to it, I just keep breakpoint.
No, but what if for example, if you have something that like a null pointer error or something like that, that will still and it's thrown in one of your slots. Like one of your slots throws a null pointer or something. You'll get an invocation error, but if you look through the stack trace, you'll get to the null pointer error. So I mean, you do have to go. Our hands are tied with reflection. I mean, we can't do anything about it because we don't even. The program doesn't even know what the method that you called is before it's called. So I mean, you just have to go through. I mean, that's the restrictions. You have to go through the stack.
I think I just got the first it was like one day. It was like a week ago.
Right. No, but if errors are actually being hidden.
No, I got a couple of them. Like what'll happen? No error throws, and it just keeps on going. And what I'm expecting to happen didn't happen. I'm like, what the hell?
Wait, because if you're throwing something, are you saying throwing a normal error? You want to throw a normal exception, an exception that you want to throw so that you can catch it somewhere else? Or?
I've had instances where it was supposed to do something and it didn't do it, and I didn't get an error, and then so I kept just breakpoint, and I figured out I had the breakpoint, so I got there. Once I got there, I was able to say, oh, I made a mistake here, but I never got the stack trace or anything.
Okay, if you're not seeing a throw, if you're not seeing a catch, then if you're not seeing a throw and error, that's being hidden somewhere else. That's not by this.
Yeah, I know. I said that right.
Okay. What I'm saying is that it hides errors in the sense that it's going to hide any error that's any exception that's thrown in your program within the invocation error, and then you have to go down the stack until you.
Those are okay. I didn't have a problem.
Oh, okay. I thought you were saying something was being hidden somewhere.
Oh, no. It was like that one. I think it took me 3 hours. It was something stupid too. I was so pissed.
Love those exceptions. I see.
Although I've been working with C, and I much prefer Java now because it's stuff like no point exception you really appreciate.
Oh yeah, I mean the printouts, but I don't know. At least old programs have the courtesy to just crash.
Whatever.
Yeah.
Just keep going.
Java's all about kind of working. This program kind of works. All right. Oh, you got anything else? Everybody cool? Read papers, because I need you guys to write something by the end of this too.
Okay.
I mean, you guys are doing all right on code at this point. Shock and awe. You guys are doing pretty good in code. I need something written. And here's some incentive. Write something that I can use in a paper, and you will be put on the paper when I submit it to conferences or journals and whatnot. Okay? that is a big deal. If you can get like at least just like a conference paper or something like that as an undergrad, that would be completely impressive to. I don't know about employers, like business world employers, but at least grad school, and graduate school and stuff like that. Even if it's not for an application, it will impress somebody who you were trying to apply as a student for them to advise you. So, things that are good to write. If you want to get your hands dirty, it's getting into some of these papers and critiquing or whatever, a method, coming up with some things that you could do with that method, some better ways of doing what they're trying to solve, that kind of thing. But as far as just getting started, what I'd really recommend is survey types of activities. And what I mean by survey types of activities is reading through some of the papers and saying, oh, this is a style of doing, like, for example, file transfer over a peer-to-peer network. I'm going to read this other paper that also does file transfer. I'm going to compare the two and see what kind of things they have in common. These are the common issues that come up with file transfer, and here's how this one solves it, here's how that one solves it. The papers that are out there are a good model of what you should write. You'll notice they all follow the same format. They have an introduction, usually a little bit of related work, background stuff. I recommend that related work type of style because that's like the survey style where you can look at a couple different papers, see something in common with them, and something to be addressed in them, types of things. So you'll notice a paper is here's an introduction, which is kind of a summary of the whole paper, but then you have related work, and then you have a new method, which says, as you saw in the if you saw in the related works, there's this problem. Here's how we solve that, and how we do better than those other things we saw in the related work. Then you see some experiments, some results, and then you see a conclusion. Okay, something along those lines would be really good with these peer-to-peer things. Whether it's looking at the overlay networks, whether it's looking at the applications like the search and stuff like that. But soon we're running out of weeks. Okay, so read stuff. Propose something to me that you're going to write. And like I said, one incentive is I need some grades to I need some grades to give you. Otherwise, I can't give you any grade in the class. And the other incentive, which I think is actually more important, is writing something of paper quality that we can put together into a paper, and get published. Which again I think is more important. And if you write a whole paper that's conference caliber, I'll help you, submit it, wherever you wanna, if you wanna submit it to a conference or something like that. If not, if you want to get your feet wet with it, I'd be happy to roll it into what I'm working on with this platform and everything, and then turn it into something that's like a conference paper, and then submit you along with it. Okay.